Hello, everybody. This is Andrew Gums. This is our 60th episode of Artificial Intelligence and Cybersurgery, our podcast, our official podcast for the journal Artificial Intelligence Surgery. We're the first journal dedicated exclusively to artificial intelligence and surgery. And I will let my co-host, Professor Dr. Vincent Grasso, introduce our illustrious next guest who is going to close out season 2. As this is episode 60 of season 2. Go ahead.
Yeah, it's fantastic. Episode 60 came pretty fast, Andrew. So we're excited to have Bartek on, Professor Stanczyk. He's a very interesting guy, multi-dimensional. But on this call, we'll be talking about his very interesting company, ACCREA Robotics. He's got a very interesting engineering group and robotics entity in Lublin, Poland, where Andrew and I were recently at. We'll be doing work out of there. It's very exciting. So Bartek, thanks for joining episode 60. And please give our audience an intro to your background and your educational background and work that you're doing. So welcome to the podcast.
And how you
Thank you for having me.
And how you say your first name. Your official.
Well, it's in English. In English, it's Bartholomew, so you're free to call me Bart. Yeah. The Polish version is Bartek. Obviously, I was born and raised in Lublin, Poland, studied here in electrical engineering. Worked at the university, did some teaching, moved to Berlin and Munich, Germany, where I actually did some serious robotics for the first time, did my PhD in Munich in a project, which was fascinating. It was a big project for teleoperation in robotics with force feedback. It was more than 20 years ago, and we had all the big players like DLR, which is German NASA. We had the German Army. So we had this use case about, remote disarming of explosives, for example, or remote maintenance on a spaceship. So this was when I got in touch into, robotics. We've been building robots for remote operation with haptic interfaces, with controllers, all this stuff. And back then we thought, robots are too stupid to do anything on their own. That's why they have to be teleoperated. Partially, it's still like this, but the operating principle was exactly like you do operate till today with Da Vinci. So you're always in control as a surgeon. You move only, the robot moves only when you move it, so that was that principle. After that, I founded our company, ACCREA, more or less a bit of an accident because the guys at the university, they said, wow, your robots are so great. We just all of a sudden need 10 pieces of them. And it was like big robot with 2 arms, a head, a multi-directional platform to move around in human environment. And they wanted to do stuff like, they called it skill transfer. I tend to call it like this till today. So we look how humans perform some motions like pick and play, so play soccer, play billiard, learn those skills and transfer them on the robots to repeat it. Kind of something we're still trying to get this today, even in surgery, right? So we might look into this subject. Anyway, we started building those robots, and then we had this company here in Lublin.
But Bartek, were you using like reinforcement learning algorithms for that, or
no? Well, yes, kind of. Yes and no. It was 20 years ago. So we were trying to, do some not that advanced stuff because our computers were pretty poor. But yes, it was kind of reinforced learning. It was mostly about, understanding how these motions can be first broken down into skills and movements and some very basic motion primitives, and then learning this.
I could already tell we need Bartek on another podcast, because I have it's so wonderful to talk to you like this about robots. But before we get even deeper into robots, I would love to know why you went into robots. As a kid, did you know, or was it really during that experience in university that turned you on? Like, why did you want to become an engineer in the first place?
Difficult to say. I always played with some mechanical, electromechanical stuff like motors. I've built my. I know today these were mobile robots, but basically I wanted to build a tank, with the caterpillars and moving left and right. And then I realized you need the motors to control, the right and left caterpillar doing different speeds. Okay, so you can turn and then you can rotate in spot. So I figured it out as a kid in elementary school, and I also pretty much in audio electronics. So I couldn't afford an amplifier, so I had to build one. Yeah, this is how I got together the mechanics, the electronics. Then I built my own motor driver, motor controller. We were disassembling, hard drives from the computers to get motors out of it. It was beginning of the 90s. It was basically, Eastern Poland. You cannot afford anything, so you need to recycle a lot, which was good, I must say.
So you learned a hell of a lot. What is it? What's the mother of necessity is the mother of invention.
Necessity, yes.
Interesting.
Yeah, that was also the reason I went to Germany. I wanted to learn like proper engineering, proper robotics, and this is I've found, perhaps the best university to do it. And then I happened to be the part of a really great team back then. I'm really thankful for this.
And how did you find out about that team? And can you tell us a little bit more about it?
I did some research in Germany. I basically wrote to every professor who was doing control and robotics. And yeah, had a lot of interviews, and I chose this one. Basically, I first chose Berlin, and then the professor moved to Munich, which was a very good move. Yeah, I actively searched for one, and I searched for robotics.
And did you speak German already?
No.
You
No,
learned it when you
no.
got there.
Not at all. I've learned when I get there. I even had to teach I think in the first year when I landed in Berlin, and they didn't want me to teach in English. So yeah, go ahead and learn German.
And can you, the reason I'm interested in this is my father's originally from the Caribbean, and he was in a British island, and he went to medical school in Italy. So he studied Italian for 2 or 3 months in Perugia, and then he dove into medical school in Bologna. And as you know, to this day, that blows my mind. So you sound like you did something very similar. I mean, how long did you have to learn German before you were actually in front of people trying to teach in another language? That blows my mind.
7 months, 7 months,
6 months?
something like this. Yeah. But I'm a weirdo about languages. I'm into spaced repetition, right? Like you reinforce learning on yourself, like you hack your brain a bit. So, but that's possible, and I think no language course should take you more than half a year, if you ask me.
And how many languages do you speak then?
5.
Which ones?
A little bit of Italian,
Yeah.
Russian. I'm fluent in Russian, German, Esperanto. I tried to learn some of the
How did somebody
some of
learn
the local Slavic
Esperanto?
languages.
How did you learn Esperanto? That is, where did you study that?
Well, on your own. Normally the full course of Esperanto is 6 months.
Wow.
But if you happen to speak Italian, you can do it in 2 months. This is because Esperanto works like a mathematical formula. You get perhaps a few hundred of roots from which you form different vocabulary.
Yeah.
And some formulas to make make a plural, make a negative, make an adjective out of one root, and same for grammar. It's just so you have this basic set of roots and 16 rules. That's it.
Wow.
All the mathematical formulas to make a language, and that's fascinating. That's really fascinating. All you need to make a language, and you can read a book after this course. Not a simplified, teach yourself, easy readers. Just go and read a novel.
Wow.
That's impossible in any other language.
So you realize the type of brain we're dealing with here, Vincent.
Bartek's a scary guy.
I think we found the genius, the other genius in the group. We got two now out of three. Okay, so you're now in Germany. You're working with one of the top robotics professors in Germany at the time. You're working on diffusing bombs with robots, and then they like your arms so much that they put an order in. This is where we last left off with you, correct?
They
Okay.
put an order, and of course I couldn't do it myself, so I had to establish some company. I had to hire some people, do some CAD design. We also wanted to optimize something because the university wanted some changes, they wanted some improvements, blah blah blah. So, and it's not that easy to make a robot because you need mechanical guys, you need electronics guys, you need computer science, you need the control guys. So I've established this team here, and the university came. Okay, so let's do some R&D projects, and this is what we were doing for like 10 years. The EU has this program for universities for research consortia, and all universities, they need someone to do the dirty work for them, to solder, to do the mechanical part, to design hardware, so that they can do their happy research, happy hacking. And we're doing this for good 10 years, several
So
projects.
this was after your PhD. You're now a postdoc at this time.
Yeah.
Okay.
It was after my PhD. So we were working mostly in some human-robot cooperation, collaboration, interaction, both socially and also physically. So we had a project on social interaction. We're building a robot that would ask the way in Munich from the university to one of the main square, just by asking the way, and get there. No Google Maps, no nothing. And it needs to approach people in the streets, the pedestrians, and to ask them in a social way so that they can deliver information. And it has to figure out the whole map. You need to go straight, right? And you basically start from okay, Munich is cobblestones, and you want to approach people also sideways. So you need to develop like a social way of approaching people on
Like
cobblestone.
Like a social tank that can move left,
Yeah,
right, and can
exactly.
manage the cobblestones. Yeah.
Exactly. And you need to have a face which can produce emotions and understand people's emotions. So that was a very complex project. Very nice. Many people did PhDs, and I was with this robot on several exhibitions. And you tell this story, how fascinating it is, and you end up hearing this question. Okay, so what is it good for? So the honest answer was, well, it's good for not many things. So which like triggered also me into, okay, well, actually we should do robots which are doing something useful. Also, but also in this human context. So then we had some projects on robots that help you walk, like we had an intelligent walker. We had a robot for doing remote ultrasound, which is nothing else but teleoperating an ultrasound probe. A robot for caregiving people with dementia and Alzheimer. That was very interesting. Yeah, but after some time, we realized that universities have a little bit different agenda than putting products on the market. It took me some time to understand this, and we thought, okay, so we have accumulated so many technologies that we have to do it on our own, and we spin off those products into the market, and we learn how it is to develop and to market a medical product. I also, just to do the full picture, I happen to work as a consultant for two companies in Germany who were developing robots like Da Vinci. One was developing more like a CMR robot, like individual arms, and the other one was like this monolithic Da Vinci-like robot. So this way, I also got excited about this use case.
Can you tell us the names of those companies, even though I think I know?
The last one was Avatera.
Yeah.
Avatera, and the previous one was Avra Surgical. It changed its names. Basically, this company or this technology later on became the Medtronic,
The
which is
Hugo.
also developed in the vicinity of Munich. So same team, same people.
So I didn't know
moving
that. So
over.
the Hugo is developed in Germany?
Yes, it was essentially developed within the same project this teleoperation project within the DLR, German NASA, Deutsche Luft- und Raumfahrtzentrum.
Yeah.
This was basically the visionary professor who was there was Professor Hilsinger. He developed this lightweight robots, the robot which was also later on licensed / given to KUKA to make the KUKA lightweight KUKA Med surgical robot. And there was another division developing the robotic system called Miro. And the Miro lab was then licensed to Medtronic, and they made Hugo out of it, which is like completely different robots, if you ask me.
Right, yeah.
Miro was really beautiful, sleek, and beautiful robotic arm. And Hugo is a little bit different.
Yeah, no, yeah. Tell us a little bit more about that. I mean, they're definitely. I've only seen the final product of the Hugo,
Yeah.
and it is a, not a svelte device. Why do you think that is? Is it just cheaper to? Is it cheaper to build? Why did they make that change? Do you think to a larger monolithic device?
Well, Hugo still has this concept of individual arms. On each of them has its own column and a tray, so you maneuver them as you wish. You can put them on the both side of the table. But the original Miro arm was really anthropomorphic. Was more like CMR armed, having a shoulder, a wrist, and an elbow, and an instrument in the hand, basically.
Yeah.
Whereas when you look at Hugo right now, it has this mechanism. The individual arm of Hugo looks like a Da Vinci arm with this remote center of motion being held mechanically. And I think this was they must have heard. I don't really know, but I suspect that they must have had concerns with the center of motion, the trocar point, being held only by software. So they must have had some concerns, and they went for a mechanical solution which just keeps it steady in space. It's safer. It puts less requirements on your control system, but makes the robot bigger, bulkier, and less sleek in compared to Hugo to Miro. Yeah.
So, you touched about something which has fascinated since I moved to Europe, and I don't remember it being like this exactly in the United States, but in Europe, I've noticed the universities really don't seem to care about a research project ever generating money. And, I remember in America, the discussion of money was paramount, and then the research idea came second. But in Europe, I've noticed that the idea is paramount, and whether or not it can make money seems to not even be discussed, which is a beautiful concept. But I'll let Vincent tackle that. What do you like about that concept, and what do you not like about that concept? Doing research for the sake of research, and then on the other hand, doing research to have a product that can actually generate money.
My experience is that if you're gonna do research that doesn't have a direct near-term commercial value proposition, you want to encourage research that's going to be groundbreaking, things that are going to change the industry perhaps, and they themselves don't have a commercial value, but you need that kind of very insightful genius level research so that you can make the breakthroughs and things that the rest of us need. So it's really, I would think the best blending would be research that has, two efforts: the groundbreaking, very exotic research, coupled to a team that's also working on research for commercialization, like the MIT Media Lab. Everything that they kind of do there is designed to have some commercial benefit, and that's the purpose of the Media Lab. So it's a blending, but I think both sides, if you're just 100% on one side or the other, that's not so great. But I think the European schools would benefit from research that has a deeper understanding of its commercial merits, because then you get dividends back on your patent portfolio, and that fuels more research, right? So that's kind of where I think would be the best of both worlds. But what is Bartek? What do you think?
I don't really know the American system so much. I'm deeply here in Europe. I also have another hat. I work as an expert at the European Commission, monitoring, helping them to monitor the projects also, which are finishing and looking at their auditing their results and so on. And to be honest, I don't have the official statistics. I don't think anyone dares to publish them, which would be how many projects finish up
A product.
with products and even with attempts to make it a product. And because the number would be so low, I must say. I think it's the mindset. There's not so much pressure for at the universities that to commercialize the results. And we're not talking about basic research. We're talking about robotics, and robotics is applied in most cases because you don't do basic research in robotics anymore. If you ask me, the whole robotics was invented in the 70s already, all the mathematics and so on. So all it's about applied, putting robots into different areas, different applications where, for example, we couldn't achieve because of the computers had too little computing power, or the hardware was too expensive. So this is all applied, and if it's applied, then I think it should be applied to the end, to the product. So I'm fully with you. We should really put efforts into commercializing this, but we realized this a couple of years ago. And I think it's all about individuals who are getting excited about the product, also having the understanding for the business side of it and driving it further. There is also no obstacles from the universities that if you find, okay, we had such a great project, let's commercialize it. So the universities don't prohibit you from doing it.
See, that's also a very interesting thing. In America, whenever you develop anything, basically, the university swoops in, and just to be simple, they essentially own your patent, they own your research, they own your work. And in Europe, it's the exact opposite. And tell me if I'm wrong, but my experience has been is that the university is very hands-off with whatever a lab, even if the university funded the lab, they're much more generous with who owns the patent and the intellectual property, which was, again, mind-blowing to me. Because when I came to Europe, when I moved here 6 years ago, I was actually impressed with the amount of research in artificial intelligence in healthcare, the amount of research they had done on augmented reality, the amount of money that they had put into projects that had been going on for years, over a decade, over a decade and a half, sometimes 2 decades, with no viable project. But the reality is I saw a lot of advancements in AI in Europe, more so than I noticed in America. I mean, America, of course, has, the Da Vinci robot, fine, that's beautiful, but, it's not really using artificial intelligence. It's, as we all know, it's not a true robot. It's just telemanipulation and all these, I think we don't have much time to go into that, but I'm actually equally impressed by the amount of innovation that has been happening in Europe in AI, because that ramp up was an economic loser, but Europe was willing to absorb that to advance the field. So that's also the positive aspect that I've noticed. And right now, my goodness, if I was an investor, if I was actually had some money, I would spend 6 months in Europe visiting all these wonderful places and investing heavily. I'll put it to you that way. So Vincent, you came to Poland recently. You visited Bartek's company. You were able to see what they've been able to accomplish. Have you seen something similar? Can you imagine a similar setup somewhere in the United States like that?
Oh, I was really impressed with the level of, academic excellence and seriousness and focus, and actually, people working nicely together without, the battles and things that we see. So that was refreshing. Bartek has a fantastic company and team. It's interesting. I think this kind of brings to mind in the old days with Einstein, there was prejudice against Jewish physicists, and they weren't able to be experimental physicists. They had to be theoretical physicists. And they wound up figuring out very interesting things because they were blocked from being guys that literally built stuff. Fermi's genius was that he was equally good at both sides, and look what he accomplished. So we need the brainiacs to think abstractly, but then we also need the people that can implement what they come up with. I think I see a lot of that opportunity in Poland, which really impressed us both, right, Andrew, in our stay there. So we're excited to continue the conversation, Bartek, with you on this interesting topic, especially as it applies to robots.
So I think we only have a few minutes left here. Bartek, maybe you can tell us what ACCREA has been up to recently, or do you want to keep that top secret? I'm not really sure how to play that, so I'll leave that a nice open question.
I'm happy to share. Since we've accumulated so many technologies in the area of robotics, we are essentially working on a robotic platform of different robots, and we're mostly about manipulations. And when I say robot, it's mostly a robotic arm, which is doing to act and manipulate just like a human arm. So we have different arms. And we give these arms different instruments. Like the most obvious are laparoscopic instruments or just simple cameras to hold them. We position the arms at different places within the operational theater. You can position them at the table or a column or at the ceiling. So these are basically like hardware modules which allow you to perform different interventions. And we're, of course, looking at different, from the business perspective, at the most lucrative ones. And we found that talking about high volume interventions, we're talking laparoscopic interventions. And how can we support this field is that we have surgeons and we have robots working symbiotically towards the common goal. So, and we looked at the task first for these robots are relatively simple. You just support the surgeon in terms of you hold the camera, you deliver the optimal view, optimal angle, and you support also holding retractors and tissue. So this is what we are doing with our first use case. And I think it's going to be really massive because of its volume. And then working on robots for biopsies, which from our perspective could be seen as like microsurgery. Once you've taken a tissue sample, you've done your diagnostics, it's cancer, you can burn it by means of ablation. There are different technologies for this. So this is also what we're working on. But it's another you would call it an app on your base core technology, and the core technology is both hardware and software. So it blends together because these technologies are in many cases very, very similar, but the apps are different. And we have some more apps in the pipeline, and I'll be quiet about it right now. But there is a massive thing you can achieve with these technologies. We are definitely thinking about introducing autonomy. Everybody's talking about AI, but for me, AI is first step in robotics is introducing small steps of autonomy so that the robots are doing some actual work. Like I've heard from many surgeons that right now the only robotic or mechanical device which is performing some work for surgeons is a stapler. It's staples, right? So you as a surgeon, you give a command now, staple, and it staples. Yeah. So I think it will go this way, that we'll be introducing such small, call it skills, and they would be supervised but done autonomously until all those skills at some point will puzzle up to more complicated intervention. So this is what we're working on in the background.
So yeah, part of we break up procedures when we talk about autonomy into surgemes. Like a gastrojejunectomy would be a surgeme during a Whipple procedure. And then a surgeme is broken up in even smaller parts, and we call them deck seams. Do you use those terms also in Germany? We're using.
I've seen this in literature being having different names. We tend to call them skills out of my heritage, but it's basically the same thing. That you need to break it down to smallest units you can learn and teach the robot, whatever it is, and it will be for different applications. Will be different. I'm sure.
Yeah. Yeah, we wrote a white paper on this a few years back, talking about this, and we're probably going to need to revisit that, Vincent. I think we're going to have to get Bartek on that paper. I think we're going to have to probably time for a consensus conference on that also. But that reminds me, in the last few minutes, we are doing a consensus conference on new terminology for surgery. You know, we don't think of surgery anymore as just traditional, you know, laparoscopic or what they call robotic now, or laparotomy, but it's also, like you mentioned, percutaneous surgery, you know, with the robot you're mentioning, the second one that does the ablations, or endoluminal surgery when they do surgery through a natural orifice, or, you know, also some people, you know, it kind of overlaps with the term NOTES, natural orifice transluminal endoscopic surgery. But we also, you know, part of that consensus conference, we really have a problem with the term console surgery, non-console surgery, handheld robotics, cobots. What's a cobot? What level of autonomy? What have you? But Vincent, I think you'll agree with me that we need to have Bartek speak on robotics, and maybe Bartek, if you could think about a 10 or 15-minute talk about maybe terms that surgeons could help us understand what robotics is. Because I mean, the term I use, the definition for a robot that I use, you know, robot comes from the Slavic word robo or robot. I don't know how it's pronounced. Maybe you do, Bartek, but it means servant, or probably more appropriately slave, because the robot is actually, as you mentioned, actually doing the work. So for me, I like the simplest form of a definition of a robot is a device that replicates the actions of a human. What would you define a robot as? Or I'll let you think about it for your presentation if you would rather.
Okay, I'll do one. I'll think about it. Sure.
Yeah, we'll let you think about it. But these are the type of things that we would love to have you help us articulate to surgeons what a robot is, what a surgical robot is, you know, what the telemanipulator is, how that's different. Is this a true surgeme? Is this not a surgeme? Is this is this an autonomous deck seam or not? It would be great to have you there as a robotic expert to kind of help us, because we need, you know, surgeons, endoscopists, interventional radiologists, and engineers and ethicists and everything to help define really this new and an exciting field. So with that, Vincent, I'm gonna let you, if you can ask Bartek a question. We have about 3 minutes, and then I'm gonna let you close it out.
All right. You know what, Bartek, I want to do? I want to create some vocabulary in Esperanto with you on surgical robotics. We'll create our own little. We'll probably get more notoriety and newsworthiness by doing that, Andrew. We'll be on talk shows all over the place.
Right.
But you know, I'd like to talk more about, you know, the levels of autonomy that we talk about, and how these definitions and terms would apply through level 0 to level 5, right? So that's going to be very interesting. I think that part of the challenges are what are the economic impacts and the risk profile as we ramp up from 0 to 1 to 2 to 3 to 4 to 5, right? Because if you build something that's risky but solves some problems, then there's what's the economic consequence or impact? So maybe we could talk about that too, Andrew, and, you know, drill these things down to economics and finance, because that's going to help us communicate the value of this stuff to the people that make purchases, right? They're interested in that. So that could be something interesting. But, you know, I think this has been an excellent podcast. Bartek, you're closing out season 2, episode 60. And Andrew, how about we have him back on season 3 with some updates on, you know, his robotic innovations and things, and making some progress on these definitions like you mentioned. No,
absolutely. We need you more often. It's I'm kind of shocked it took us to get to episode 60 to finally get you on the show, Bartek. You're a busy man, and we really thank you for taking time out from your children and your family on the weekend.
Thank you for having me. Fascinating.
All right.